Alright, so here's some examples that go along with the mean value theorem. The first one says verify that the function satisfies the hypotheses of the mean value theorem on the given interval. Then find all the numbers C that satisfy the conclusion of Rolle's theorem. So, mean value theorem, not Rolle's theorem. A lot like the problems that we did when we were doing Rolle's theorem. So here's our function. F of x is equal to x cubed minus 3x plus 2 and negative 2 to 2. So here's our function, there's our interval. So the conditions of the mean value theorem are that it is continuous and differentiable on this interval. Well, this is a polynomial function, and things we know about polynomial functions is that they are differentiable and continuous on the entire real line from negative infinity to positive infinity. So they're definitely differentiable on any closed interval inside the real numbers. So now we know for a fact there's some f prime of c that equals the slope of the secant line between these 2 points. So let's go ahead and find these endpoints. F of 2 is equal to 2 cubed minus 3 times 2 plus 2. See, 8 minus 6 is 2 plus 2 is equal to 4. So now we got f of negative 2, which is negative 2 cubed minus 3 times negative 2 plus 2. See, this is negative 8. This right here is plus 6. Negative 8 plus 6 is negative 2 plus 2 and 0. Okay, so now this right here could be like my f of a. This right here, that could be my f of b. That one's my f of a. This is like a, and that's like b. So let's go ahead and find the slope of the secant line. M is equal to f of b, so f of b, which is 4, minus f of a, which is 0, divided by b, which is 2, minus a, which is negative 2. So on top you get a 4. 4 minus 0 is 4. On bottom, 2 minus a negative 2 is 2 plus 2. You get a 4 on bottom as well, which is equal to 1. Okay, we don't need these. We already have our slope. I'll rewrite it up over there. M is equal to 1. So according to the mean value theorem, there is some c number such that f prime of c is equal to 1. Now, there could be more than one number c. We don't know. That's what we're going to find out. But if we do find a number, we have to make sure it's within this interval, because that is what the mean value theorem is guaranteeing. Okay? We should find one in that interval, so we need to find the derivative. F prime of x is equal to 3x squared minus 3. Now if I plug in c and set it equal to 1, you get 3c squared minus 3 is equal to 1. Plus 3, plus 3. 3c squared is equal to 4. Divide by 3, divide by 3. C squared is equal to 4 over 3. Square root, square root. Get c is equal to plus or minus. Now I'll give you the full answer, like fully rationalized and everything. 2 root 3 over 3. So those are our c values. Okay. I do not have my calculator here with me. Give me one moment. I'll be right back. Let me go grab it. No, go away. Alright, let's see. Got the calculator. 2 square root 3 divided by 3. That's 1.154. Okay? So this right here, we've got our C values, which are approximately plus or minus 1.154. So we found two values that are in this interval where the derivative has a slope equal to 1. Now, if you were to take this number, plug it in, you should in fact get number 1. Now, you should take a moment, pause the video, go ahead and do one of the problems that I told you guys to try. It's doing the same thing, verify the hypotheses of the mean value theorem, but for the function 1 over x. Okay, so now we're going to do a different example. Show that 2x plus cosine x equals 0 only has exactly one real root. I'm going to prove to you that it only has exactly one real root. So what we need to do is we first need to show that there exists a root. Now, if you recall back to chapter 2, the intermediate value theorem, okay? The intermediate value theorem says that if you can find a sign switch, f of a is less than f of b, or sorry, a is less than b, f of a is negative, f of b is positive, that means somewhere along there is a 0. So let's call this function f of x is equal to 2x plus cosine x. Alright, now let's look at this interval negative pi over 2 to 0. So if you remember how to do these, if you just plug in the endpoints, 2 times negative pi over 2 plus cosine of negative pi over 2. Well, let's see, 2's cancel here is equal to negative pi plus, well, cosine of pi over 2 is 0, so cosine of negative pi over 2 is also 0. Right here, you get plus 0, which is just equal to negative pi. Okay? So, let's see. Get rid of this. Let's move our function up here. F of x is equal to 2x plus cosine x. Let's move our interval, negative pi over 2 to 0. Bracket. And we just showed f of negative pi over 2 is equal to negative pi, which is less than 0. Okay, let's find our other endpoint, f of 0, which is equal to 2 times 0, well, that's 0, plus cosine of 0. Cosine of 0 is equal to 1. Well, that's greater than 0. So, we know for a fact, by the intermediate value theorem, there exists at least one 0 on this interval. Remember, it could be more than 1 because negative pi over 2, here's 0. The function could go something like that. Okay? So our job is to prove that it has only exactly one 0. We know there is a 0 there. Could there be more than one? So now, let's suppose there are 2 zeros, okay? So we only have to do 2. We could do more than 2, but it would be the same, the proof would be very analogous. So if there's not 2, and you extend it out to 3, there's not 3 or 4 or 5 or 6, there has to only be 1, okay? So suppose that there are 2 zeros. What that means are 2 zeros for some x1 and x2 in the interval negative pi over 2, comma 0. So if there are 2 zeros here, that means f of x1 is equal to f of x2. This is a linear function. This is continuous on its domain from negative infinity to infinity, so it's continuous on a closed interval. Cosine is also continuous and differentiable on negative infinity to infinity, so it's also the same thing on any closed interval. F of x1 is equal to f of x2, which is equal to 0, because they are zeros. All 3 conditions of Rolle's theorem have been satisfied. So that means that there is some c value in this interval such that f prime of c is equal to 0. Okay? So let's go ahead and take the derivative of this. F prime of x is equal to 2 plus, or sorry, not plus, minus cosine of x. The derivative of cosine of x is negative sine of x. So now, if we were to go ahead and set this, plug in c, set this equal to 0, and try to solve, we're going to run into a problem. So 2 minus sine c is equal to 0. So if I add over the sine of c, 2 is equal to sine of c. This is a normal sine function. It doesn't matter what c is. Sine only oscillates between 1 and negative 1. You're never going to find a c value that satisfies this function here. Okay, so that means there is no c value. 1 doesn't exist such that this equality right here holds. So when we first supposed that there were 2 or more zeros, we were wrong. So that implies we should only have 1 0 on this interval. Okay. Not only that, if we look at this function, sine again, the highest value it ever goes up to is 1. So 2 minus 1 is 1. So the lowest value it ever goes down to is 0. Yeah. So, so you get a 2 here. So this function is always positive. The derivative is always positive, meaning this function is always increasing. If this function is always increasing, it never has any time to come back down and make a maximum or a minimum. Alright, so we're going to do another example. Suppose that 3 is less than or equal to f prime of x is less than or equal to 5 for all values of x. So all this is saying is the slope of the function is always between 3 and 5. Show that 18 is less than or equal to f of 8 minus f of 2 is less than or equal to 30. Okay, so we're going to assume this one, and we're going to show how we get this one. Now, we're going to use the mean value theorem here. Now, we're going to say we have a continuous differentiable function on the interval. If you saw what we had f of 8 minus f of 2. So that should give you an idea of what the b and the a are. So 3 is less than or equal to, here's the derivative. We're going to say that's equal to the mean value theorem. So f prime of c is equal to f of 8 minus f of 2 divided by 8 minus 2, which is less than or equal to 5. Well, 8 minus 2, that's 6. If I multiply both sides by 6, you get 18 is less than or equal to f of 8 minus f of 2, which is less than or equal to 30. Exactly what we wanted to show. All we did was use the mean value theorem in this middle step right here. Very easy problem.